Good afternoon, everyone. I'm Rodion Mykhailovskyi, and I'm the visitor of Summer School Science for Ukraine. Today, I would like to present you a presentation about my laboratory work, protein architecture. First of all, we should know what an enzyme is and what is its structure. To begin with, we should notice that enzyme is still a protein. So it's built up from an amino acid chain sequence, and all its properties are actually given by its amino chain. Also, it doesn't necessarily have a quaternary structure, but it also can have a tertiary as well. As talking about enzymes, they also can have cofactor and coenzyme molecules. They are additionally affect its shape and give them different properties. Like heme in my own enzyme have a different electron transfer property. Now we want to know how can we study the enzyme structure. As of today, we have a couple of methods. The first one, and the most basic and widely used, is X-ray crystallography. It has a really big advantage of the other method because it gives us exact knowledge of enzyme structure. We could know the position of every single item, all the connections, and the shape of enzyme itself. But it also has several disadvantages because it's expensive and long. It can cost like more than $3,000 per one small enzyme, and it could take up to several months to proceed it. Also, unlike the next method, it requires a real sample, which sometimes can be difficult to get. And on the other hand, we have a more modern way, and it is the help of artificial intelligence. Unlike the previous method, it doesn't require money to proceed enzymes, and it's much more faster, because not several months, but like 20 minutes per one small enzyme. Also, it can be used on theoretical enzymes and proteins because it doesn't require a real sample. We could just give it in amino acid sequence and it will give us a result. But it also has disadvantages. Because the first and the most important one is what it doesn't gives us the exact knowledge. It only gives us a prediction. Also, it haven't matched on presentation, but artificial intelligence can sometimes broke. Like it can broke a program after update, or it can update some models that it have used. So to run it in such cases, you should run it locally. But artificial intelligence is for the most of time have really large system requirements. So not every even gaming device can run it. After hearing this all, you may have a question. So why is it so important to study enzymes if it is so troublesome? We have a couple of reasons. First of all, enzymes are one of the most important proteins of our body because exactly they give us the vital to us components. Because enzymes are actually catalyzers. They accelerate the speed of reactions or even start them. When we know why enzymes are important to us, we can talk why enzymes are important in its shape. Because enzymes are catalyzers, so because of candy-lock theory, the shape of enzymes exactly give them their properties, like what reactions can they start, or how much energy they will give to it. And because of it, even the smallest mutation can seriously affect the enzyme properties. Also, when we see the shape of enzyme, know of which atom it built up, we can have a thought about how it was created by our body, and we can create it by ourselves. Also, on the ratio, we know the exact shape of very small percentage of enzymes. If we know about like 100 of thousands to a lot of millions. of enzymes. And how can we, ordinary people, see their structure? Today we have a method that allow us to view them without any hesitations. We have a PDB. PDB, or Protein Data Bank, is a website that contains a lot of different files of enzyme structures. And it also gives us opportunity to view them in 3D, like to rotate them, move them, or to zoom in them. But it's not enough. We also have a PyML. A PyML is a program to research enzyme structure more deeply. Right now you can see some images that were rendered via PyML. As you can see, we can color enzymes, we can see their different structure, and we even can see their cofactors. And as I already mentioned, it's rendered. So PyML gives us opportunity to render and animate enzymes. Together, these two programs gives us an incredible ground to research. After knowing the theory and having tools, we want to know how can we mutate them. Creating a real sample, as it was already mentioned, sometimes really difficult, and it is very troublesome to study it. So we want another method, another that doesn't require it. And as for now, we actually have it. We have artificial intelligence that's called AlphaFold 2. AlphaFold 2 right now is the forefront of solving the enzyme folding problem, because it has a really large score. It has 87 out of 100 on the most difficult enzyme entries. On images right now you can see 3 different images, and you can see green one and the blue one enzymes. Green one are the real samples of which we know structure, and the blue one are predicted one. As you can see, they are actually really close one to each other. And it becomes even better when we know that on the images are 3 one of the most difficult examples for the artificial intelligence. So we can notice how they are actually really close. So how AlphaFold 2 actually works? As an input, it takes an amino acid sequence as a string. After that, we can give it some settings. It's not necessary, but we can. If the settings are like the number of amino chains, so we don't necessarily to give it a tertiary structure. We can also give it a quaternary. Also, we can give the length of these chains, and we can select via which technology we would proceed them, like via CPU cores or GPU cores, and so on. After that, AlphaFold 2 checks if the input is already in his databases. If it's not, then it will give us 5 different entries for the possibilities of folding enzyme. Also, with them, he will give us such images. These images are colored, as you can see, and they actually gives us the information about how artificial intelligence sure in them. So using them and the already made entries, we can make our own decision on how likely each entry is, and we can pick the most likely of them. But there are actually some important details to know before working with it. As I have mentioned before, AlphaFold 2 can give us a quaternary structure, not only tertiary. But when working, it can't give us enzymes with cofactor and water molecules. It actually has a really good scientific and logical explanation. Nor we, no artificial intelligence, can predict if after folding the mutated version could have this cofactor actually, or it couldn't, and it won't give us knowledge of how these water molecules will be positioned. Right now, you can see the results of my work. On the left side, you can see the real version of cytochrome CH, and on the right side, you can see my mutated version. At the start, we should know that they are actually aligned. So, computer program moved them and rotated them to have the best match in their structure. As we can see, these three chains are actually identical, full identical. And there is three really different chains. Also, if we look more closely, each chain have 5 amino hexyls, alpha hexyls. These are the secondary structure that are created using the hydrophobic amino acids. And the mutated version have in each chain only 4 of them. It's because it loses after mutation some hydrophobic amino acids. So it have a really different folding. As a result, the mutated version actually won't have the properties of the real one. And as a result of our work, we can be ensured that it is really important to have a possibility to research the mutations without creating a real sample, because it saves money and time, and it's actually really more easily. Thanks for watching my presentation. Any questions?
You said that you need much of a system, of computer system, to run the AI fast. So how many should you spend on one computer?
As we talking about AlphaFold 2, I will talk about it because I have used it. We need like 3 terabytes of space. We need 64 gigabytes of RAM and 24 gigabytes of video RAM. So it's actually really, really a lot.
Thank you.
Any other question?
Can you move one computer? So in the first you can see the red points, and in the second you can not see.
Points are actually active water molecules, and as I have said, the program after prediction can't say where they will be located, so it just removed them.
What did you enjoy the most about doing this project? Can you speak in the microphone, please?
What did you enjoy the most?
In your research, I think.
The most I enjoyed to pick the most possible one example of out of all entries that I had, and to see how mutation of different amino acids actually change its folding shape.
Thank you, Rodion. Let's thank Rodion once again.